So welcome back. So today we do nothing but critical angle and total internal reflection. So let's begin. So let's start. I will draw one diagram first, and it is a very common diagram because this is the first diagram we have been drawing since the start of life. So this is a dense medium, this is a rare medium. So if you see the light passing through this dense medium will go away like this. Understand? This should be the diagram. Now here, as you can see, if I let's say draw the normal here, so this angle will be nothing but I. Here I is very small, okay. So I will now what I will do now is rotate the eye. Meaning what? Means if this was the let's say this could be the ray, 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 this could be the ray. Understand? So I will tell you different rays of eyes for different rays of eyes. So when eye is very small, normal refraction, as we know, happens. Then if you see, if I go like this, if let's say I draw a line here with a different color, let's say this thing, it will be like this. Understand? So and if I draw from, let's say, a different color again, from here it will go this side. Now as you can see, it is getting closer and closer to this white surface. So at a point, at some point, what will happen is that when the light ray, when the light ray will pass, light ray will go through this line at some point, at some eye. At some eye this will occur, and this eye is nothing but called the critical angle. So what is critical angle? Let me tell you the definition. Critical angle is the angle of incidence in which the denser medium corresponding to which the angle of refraction in the rarer medium is 90 degrees. Meaning what? This thing is 90 degrees to this line back. See this. So the angle of refraction becomes 90 degrees. Angle of refraction becomes 90 degrees. At that time, whatever the eye is, that is my critical angle. Understand this very clearly. Now what are the conditions so that this happen? So first condition is obviously the light has to travel from denser to rarer medium. Mind it, denser to rarer medium. And the second condition here is the light the eye has to reach the critical angle of that medium. The critical angle is fixed for a medium, we will do later. Okay, for example, the critical angle of glass is 40, close to 42. Okay, so at 42 degree, when it is going from glass to, let's say, air, it will like that, it will go like this, like this will be the diagram. Okay, this, okay, understand? So this is the basic concept of critical angle. Always remember denser to rarer. Okay, now there is a formula. Okay, so let's say this is the diagram. Let me draw the diagram. This was the thing. Now as you know, what is mu? Ag. So what will this be? Okay, what will this be? So this will be nothing but mu of A, not mu of A. It is going from, see, it is going from glass to air. So it will be Ga. So it will be nothing but sine I by sine R. Why isn't this working? Sine r. So if you see in the critical angle case, what does it become? Sine c, because I is nothing but c. Let me draw this. This is c. This is 90 degrees. So what? Sine 90. So I can say what? Sine, yes, mu of AG becomes sine C. Or actually in the problems it is obviously given 1 by AG, because this is the refractive index of glass with respect to air. So this will become nothing but sine C. Very important formula. Very important formula. Very important formula. Remember it by heart. Now understand this. Now, or you can also say mu ag 1 by, you can also say mu ag is nothing but 1 by sine c. And what is 1 by sine c? That is nothing but cosec c. Cosec c. Understand? So let's try to do one sum. Let me give you one sum. The water refractive index is, as you know, it will not be given. Remember the refractive indexes. Okay, for water it is what? 1.33 water. Okay, it will tell you the what is the critical angle of water. So you know what, this is the refractive index of water. So my critical angle sine c will be nothing but 1 by 4. Once again, 1 by 4 by 3. That thing is nothing but 4 by 3. So it will be nothing but 3 by 4. So C is nothing but 49 degrees. You have to remember this value obviously. That sine, if sine C is 3 by 4, C is 49 degrees. Understand this? How to do such kinds of sum? Mainly the refractive index will be given. You will say what is the value of sine C or C. Anything they will ask you. Understand? So let's move on to the next part. So what are the factors on which the critical angle depends? So the critical angle depends, as you have seen, sine C is equal to 1 by mu to 1. Okay, so as you can see, critical angle depends on refractive index. So what does refractive index depend on? Wavelength, temperature for this kind. Okay, I'm just writing only two. So all the factors on which the uh, refractive index depend, you have learned earlier. Critical angle also depends on that. Okay, so now we will talk about total internal reflection. What's the diagram? Done. This is the critical angle, the diagram for the critical angle. Now let's say if I bend the light a little bit more this side. Okay, so what happens if the light will be like this? You will say it will go like this. No, it suddenly skips. It suddenly skips and follows the laws of reflection. It reflects like this. It follows the laws of reflection. I. Wow. Refraction. In refraction there is reflection. Yes. This phenomenon is phenomena is known as total internal reflection, because it is happening all internally. Total internal reflection. Understand? And what are the conditions of this happening? Obviously the first one has to be, it has to be from a denser to a rarer medium, and the second thing it has to be is angle of incidence has to be greater than angle of critical angle. Okay, for that medium. Understand? These are keywords for that medium. You have to write these in the exams. Okay, so often in the exams they may ask you uh, draw the three diagrams I have drawn here together. How will you draw it? This is a very essential question. They ask you in your exams. You first draw like this, a straight line, which I can't draw because I don't have a scale. Then first you will do what? You will select a point here. Then from here you will just draw a straight line. Just do like this, do like this. Obviously you have to mention some medium here. You'll write here rarer medium. Here you will, let me change the color. Here you will write rarer medium. Here you will write denser medium. Understand? This is a very important diagram. Learn it. Okay, this is the point. You mark it. This is the point from where it is all starting. Life itself is starting. Just choose the right color. Okay, so if you see, next thing you have to do is a normal refraction you have to draw, but also draw the reflected ray. Okay, so you have to draw something like this. Next you have to draw something like this with the critical angle showing, just the critical angle, and something like this. Okay, next you have to show something like this with only reflection. Okay, so this becomes, which is the color, this becomes, you have to write I, then here you have to write I, here you have to write I, here below it you have to write I less than C, you have to write I equal to C, here you have to write I greater than C. If you draw this diagram, can't believe I have drawn it so good, you have got full marks. If they ask you draw the refraction and total internal reflection, if they say it, okay, you can do it easily if you have a laser. That sasta laser comes now, and mailers you get, on even the anywhere you will get. Okay, like in the but don't go out now to buy them. If you have any those toy lasers you get in any like toy shop, you will get. You can do with that and any glass if you have. Just tilt the laser and you will see it. Even I intend to show one experiment here so that you people understand. So here, as you can see, let's discuss this in detail now. This one, you know, obviously goes through that. Let me change the color here to blue. So in here, in the it is when, if I have not told you earlier, learn it now. I'm inserting a page here, that whenever there is a surface, when light falls on it, some part is reflected, some part is absorbed in the body, and some part is refracted. So here in the diagram, in first case, what happens is that some part is reflected, some part is refracted. In this case, second case, that is, it is again some part is reflected, some part is refracted. Here totally reflection is occurring. Here totally reflection is occurring. No refraction is there. Understand? Understand? This is the glass piece. Because if you even throw a light source at a glass piece, some part will reflect. Some part, even minuscule, we say only refraction is occurring because reflection is like 1-2%. But when you see this case, reflection is majority. That's why you say reflection is occurring. So this is it. Okay, so let's move on. So here I have a YouTube video on total internal reflection. It will do the example, and this is made by Quantum Boffin. So please don't copyright me, and thanks to Quantum Boffin. Watch the video. See this thing, they are placing a semicircular glass slab. Okay, semicircular glass slab. As you can see, there's a light ray. Now I'll pause it here and I will show something on my own also. See this. So when it is coming on a normal, you can see straight line. Understand? So let's continue and show this. Now let me tell you one thing. See, this is what will happen actually to math. First, one second. Yes. So here, as you see, why is not the brush working? Yes, it's working. So what will actually happen is that, see, this part, this will go through, but slowly, let's say at this example, it will go something like this. Okay, but as we know, glasses critical angle is 40 degrees. So at this angle it will be nothing but go like this, and after that, let's say from this angle it will not go refract, it will just follow the laws of reflection. Understand? This should happen. Let's see the example. See this slowly increasing. You can see the refraction occurring now. It's from a denser to a rarer medium. As you can see, it is going on. It is close. It's now at 20. Now it has 30. Going closer to 35. As you can see, it is going closer. Then reached 40, and as it reaches 42, it's very close to 42. See that? It's at 90. After 90, it has started total internal reflection. You can see total internal reflection. Understand this clearly. Saw the experiment. So that was an intuitive way to just show you the experiment, how that works. So now I think I'll end it here today. I'll end the chapter at last next day and start with lenses. So let's say goodbye. So bye, and nothing else to say, and like, share and subscribe, and keep spreading the content.